So in addition to knowing the 5 properties of a parallelogram, we're also going to be proving using the coordinate plane as to whether or not these quadrilaterals are actually parallelograms. And this is how we can show. All right, A through E are those 5 properties. So we could show that both pairs of opposite sides are parallel. All right, how do we show sides are parallel? We use slope. Right, we can calculate the slope to show that segments are parallel to each other. We could show both pairs of opposite sides are congruent. How do we do that? We would use our distance formula to show that the length of the sides are the same. We can show both pairs of opposite angles are congruent. That one's a little bit more difficult. All right, we would have to actually get out protractors and measure and do it that way. So we want to stick to using formulas that we are familiar with. Consecutive angles are supplementary. Same thing. The angles are hard without having a protractor and going about it that way. And we can show that both diagonals bisect each other. All right, the way we could do that is with the midpoint formula. All right, there's a 6th way. All right, and this is, again, it's how to prove a quadrilateral is a parallelogram. If we can take one pair of opposite sides, not both, just one pair, but we have to show that they are both congruent and they are parallel. All right, so to do that, this is kind of a combination. We would do distance formula for the congruent and we would do slope for the parallel. All right, A, B, and F are the ways that we are going to look to prove quadrilaterals are parallels. Just those 3 ways, okay, using the coordinate plane. So, all right, method 1, we would show that both pairs of opposite sides are congruent. All right, so looking at our picture, if we can show that side AB is congruent to side CD, and we're going to show side AD congruent to side BC, then we know it's a parallelogram. And as I said before, in order to show things have the same length, we're going to use the distance formula. All right, now, quick reminder, I'll write it down here so I have enough room. Big square root. So you take x1 minus x2, square that difference, plus y1 minus y2, square that difference. All right, a second method is to show both pairs of opposite sides are parallel. So now we want to show that side AB is parallel to side CD, and side AD is parallel to side BC. And we're going to use our slope formula. All right, just to remind you about that, and let me come back here and put a little d in front of the distance formula. Slope, we take x2 minus, oh, no we don't, we do y2 minus y1 over x2 minus x1. Almost made a big mistake there. It is y's over x's, change in y over change in x. All right, and then the third method, what we're going to do is we're going to pick one pair of our opposite sides. All right, so I'm just going to pick A, B, and C, D as my pair. So I'm going to show that AB is congruent to side CD and that side AB is parallel to side CD. So we're going to have to use distance and slope for that one. So I'm going to work and do each method with you one at a time. So we're going to do 6 problems together in the notes. And then there are 3 problems, I believe, on the practice worksheet for you to do on your own, one for each method. All right, so let's start with the first one in the distance formula. Now, the first thing you will want to do, and these directions are important, is you want to sketch a picture. Now, they don't on this worksheet, they didn't say this is shape ABCD, but the order in which the points are given tell you that they continue around in that order. And that's important to know that ABCD will continue around either clockwise or, remember when you're labeling, counterclockwise, so that you know which sides are actually opposite each other. If you zigzag, then you're going to have the wrong sides. Okay. All right. So what we need to show is we have to find the length of AB. All right. And side CD. We'll compare those two. And then we're also going to find the length of side AD and BC. All right. Distance formula. So I'm going to take points A and B. So my x's are -7 and 1. So I'll subtract those. -7 minus 1. We'll come back and square it. Then I'll subtract the y's, 4 minus 2. Square it. All right, so I've got -8 squared plus 2 squared, which is going to give me, kind of come down a little bit, we've got 64 plus 4, so the square root of 68. Right. Now I'm just going to let you leave it like that in the square root, because all we need to show is that those square roots are the same. All right, for C, D. So I'm going to subtract the x's. So I've got 9 minus 1, quantity squared, plus, and then -8 minus a -6 actually makes it a +6. Double negative becomes positive. So this time I've got +8 squared plus -2 squared, but it will come out to be the same. Square root of 64 plus 4, or the square root of 68. All right, so there I've shown that one pair of the opposite sides are congruent. Let's move on and do side A, D. Subtract the x's. So we've got -7 minus 1, square that, and then 4 minus a -6, which will become 4 plus 6. So I've got -8 that I need to square, and then I've got 10 that I need to square. So 64 plus 100 is the square root of 164. And lastly, BC, so B and C, I've got 1 minus 9, quantity squared, and then I'll have 2 minus a -8, which will really be a 2 plus 8. So you can see just as above, we've got -8 squared plus 10 squared. That's going to end up giving me, again, 64 plus 100, or the square root of 164. All right. So these are congruent. So ABCD is a parallelogram. All right, and then tell me what you just proved. So ABCD is a parallelogram because opposite sides are congruent. Okay, so that is one method. Let's take a look at the next problem. Our points are P, Q, R, S in that order. So remember, it doesn't matter where, I'm just going to start P over here this time. It doesn't matter where you start. And this time I'm going to label going counterclockwise. So this could be Q, R, S. All right, we just got to make sure we continue in the same direction. So what I need to show, I'm going to just look at my picture. I've got side QP, and then I've got RS. All right, then I would need to do QR and PS. Let's start with Q and P, which are the first 2 points. So I'm going to subtract. My x is -4 minus 6. Square that, plus, and then I'll do 2 minus 4. This will give me -10 in the first parenthesis and a -2 in the second. But when you square negatives, they always turn positive. So this is the square root of 100 plus 4, or 104. And then R and S are the third and fourth points. So I've got 11 minus 2, the quantity squared, and then I'll do -2 minus a -3, which turns it into a +3. So that will give me 9 to square, and then 1. So I've got the square root of 81 plus 1, which is the square root of 82. All right, I can stop. These are not congruent. And if I've got one pair that's not congruent, it doesn't matter if the other pair is. All right, I can stop and I can just say that PQRS is not a parallelogram because, and I can just say because side QP is not congruent to side RS, which are opposite. I guess I should say which are opposite. Okay. So obviously, it does help that we want to make sure we get our math right, because if you do make a mistake, all right, then we could obviously end up giving the wrong answer. All right, so that's if you want to show that the opposite sides are congruent. Let's take a look at the second method, where we want to show that both pairs of opposite sides are parallel. All right, so again, we've got W, X, Y, Z. Let's just sketch a picture. Start W down here and go clockwise. So I've got W, X, Y, and Z. To show parallel, we use the slope formula. So what we need to do is we're going to show the slope of, let's see, we need to do WX, side WX. We need to do the slope, and there really should be a little of in there, so it doesn't look like measure of. So we've got M, I'm sorry, I did WX, so now I need to do YZ. All right, then I've got the slope of XY and the slope of WZ. All right, so notice before I'm even getting started, I always write down what it is I need to find. It just makes it a little easier to then go back and grab the points that we need. Remember, it's change in Y over change in X. So WX, I'm going to do the Y's first. So I've got -4 minus a -6 over a -7 minus 1. This double negative is really a positive, so I end up with a +2 over -8, which is -1/4. If I use points Y and Z, I'll do the Y's first. So we've got -13 minus a -12 over 5 minus 1. So again, it's really -13 plus 12, which is -1/4. All right, so right away, these two are parallel. They have the same exact slope. All right, so we got to keep going. So now we got to check the other pair, X and Y. So I'll do -6 minus -13 over 1 minus 5. So really this is -6 plus 13, which gives me 7. And then 1 minus 5 is negative 4. And lastly, W and Z. So I'm going to do negative 4 minus a negative 12 over negative 7 minus 1. So we've got negative 4 plus 12 is 8. And negative 7 minus 1 is negative 8. That's negative 1. So this pair is not parallel. So this is not, and this is X, Y, W, Z, is not a parallelogram because both pair of opposite sides are not parallel. And you'll notice when I write my sentences, I'm using symbols like congruent and parallel, and I'm fine with that. All right, let's do one more of those. E, F, G, H. I'm going to draw my picture over here this time. E, F, G, H. All right, so I need to do the slope of side EF and HG. Then I'm going to do the slope of EH and FG. All right, let's start subtracting. So the y's first, 8 minus 10 for E and F, and then 0 minus 6. So I end up with a negative 2 over a negative 6, which becomes positive 1/3. H and G, I'll do 0 minus a negative 2, and then I've got 2 minus a negative 4. So some double negatives here, and I end up with 2 over 6, which also reduces to 1/3. All right, so these are parallel. All right, EH and FG. So E and H. So I've got 8 minus a negative 2, and then 0 minus a negative 4. Gives me 10 over 4, which becomes 5/2. And lastly, F and G. 10 minus 0, 6 over 6 minus 2, again gives us 10 over 4, or 5/2. So those also are parallel. So EF, GH is a parallelogram. Hold on, that should be an E, parallelogram, because opposite sides are parallel. All right, the last method, we got to just pick one pair, just one pair, but we have to show it's both congruent and parallel. All right, so the points are J, K, L, and M. So J, K, L, M will go in that order. So I'm going to pick JM and KL. Okay, doesn't matter. I just need one pair. So I'm going to do the distance for JM and KL, and then I'm also going to do the slope of JM and KL. Now notice I wrote these without bars, all right, because I'll get the measure of those by doing the distance formula. And then here I want the slope of the segment. So the bar is there. All right, J and M. Inside the distance formula, first we subtract the x's. So I've got -9 minus a -3. So that becomes a +3. Square it. And then behind plus I'll have -2 minus a -7. So again, it becomes a +7. All right. So I've got -6 that I'm going to square in the front. and positive 5, I'll square in the back. So I end up with the square root of 36 plus 25, which is 61. Then I'll do K and L. All right, X is first. So negative 5 minus 1, square it, plus 1 minus a negative 4 becomes a plus 4. So again, we've got negative 6 to square, and then positive 5 to square. So we end up with, again, 36 plus 25, which is the square root of 61. So that pair, they are congruent. Let's see if they are parallel. All right, so now we subtract the y's first. So negative 2 minus a negative 7 makes it negative 2 plus 7. The x's would be negative 9 minus a negative 3, so negative 9 plus 3. So our slope is going to end up as 5 over negative 6. K and L, so I've got 1 minus a negative 4, and then negative 5 minus 1. So I've got 5 over negative 6. Same thing. All right. So JKLM is a parallelogram because one pair of opposite sides is both congruent and parallel. All right, and then lastly, STUV. I'm going to go counterclockwise this time. So STUV. And let's do same thing. I'll do the side ones here, ST and VU. So we're going to do the distance for ST and VU. And then we're going to also do the slope. All right, let's start with distance. S and T are my first and second. Subtract the x's, so 1 minus 10, the quantity squared, plus 5 minus 7, quantity squared. So I've got negative 9 to square in the front and negative 2 to square in the back, which is going to give me the square root of 81 plus 4, or the square root of 85. And then V to U, again, 14 minus a negative 3 makes it 14 plus 3. And then 1 minus a negative 1 makes it 1 plus 1. So we've got 17 squared plus 2 squared. Whoops, or maybe get my calculator. 17 squared is 289. Plus a 4 is the square root of 293. So these are not congruent. I don't need to go any further. I can stop. All right. So STUV is not a parallelogram because side ST and side VU, which are opposite, that should be in there, which are opposite sides, are not congruent. All right, so the notes were a little long because we did 6 problems together. The practice, there are 3 that you will now do on your own and prove to me whether they are or are not parallelograms. All right, come see me if you have any questions.